Okay, here we go with Chapter 9. Chapter 9 begins with graphing the quadratic equation ax squared plus c. Now, we've been working with quadratic equations all through Chapter 8, and so now what we're going to do is just be graphing some of those quadratic equations that we have already been working with. And today we're just going to learn about the graphs and how we graph them and what each of the parts of the graph mean, or each of the parts of the equation means. Okay, so we're going to start off with learning about the parent quadratic function. This is the most basic quadratic function in the family of quadratic functions, and it's called the parent quadratic function, and it's y equals x squared. It's very basic, very simple. Okay, the graph is shown over here to the right here. Here's the graph of y equals x squared. Okay, just to show you this, the lowest point of a parabola, because this is a parabola, this shape, the lowest point of a parabola is called the vertex. Okay, so that would be right here. This point right here, the lowest point of the parabola is the vertex. And the vertex of this particular parabola is 0, 0. Okay, all right. The line that passes through the vertex and divides the parabola into two symmetric parts, this line right here, okay, this is called the axis of symmetry. And we will be using this term a lot. We'll be using the vertex and the axis of symmetry to graph a lot of these parabolas. So that would be this line right here that perfectly divides this parabola in half. And as we graph these, you'll see that on either side of that line of symmetry, or axis of symmetry, the points will be the same across the way. This point right here, where it intersects, is the same as this point right here. The y value will be the same. Whereas the x value is positive on this side, negative here, the y value will be the same. And that will show you how they are symmetrical across this axis of symmetry. So this particular parabola's axis of symmetry is the y-axis, or the line x equals 0. We will be finding the lines that are the axis of symmetry eventually as we graph these. So those are the two terms that you really need to take out of this lesson, is the vertex and axis of symmetry. And this one talks about the lowest point of the vertex. Sometimes the vertex can be the highest point, and we'll learn about that in a little bit. So right up here you might want to write highest point sometimes. Just so you know, the vertex may not always be the lowest point. Okay? All right, so let's go ahead and look at some of these examples and how these different coefficients will affect the graphs. So the first one we're going to start with is y equals ax squared. The parent equation, remember the parent graph was y equals x squared. So now we're going to look at something where it's y equals ax squared, where a, our coefficient in front of that x squared, is greater than 1. Okay, where it's greater than 1. All right, so now we're going to graph y equals 3x squared. Our a is now a 3. And the way we're going to graph this is just by making a table of values. We've done this before for lines. Now we're going to do it for parabolas or for quadratic equations. So we're going to make a table of values. So when negative 2 is x, or when x is negative 2, negative 2 squared, remember, negative 2 times negative 2 is positive 4. So 3 times 4 is positive 12. Okay? And when x is negative 1 squared is just 1. 3 times 1 is 3. And when x is 0, 0 squared is still 0, and 3 times 0 is 0. All right, now let's put our 1 in. When x is 1, well, again, 1 squared is 1, and 3 times 1 is 3. And 2 squared is 4, and 4 times 3 is 12. So notice when our x's are negative or positive, okay, negative 2, positive 2, our y values end up being the same. They end up being identical, okay? So now step 2 for graphing this, this quadratic equation is plotting the points and drawing a smooth curve through the points. We're going to count by 2's. So this is going to be 2, 4, 6, 8, 10, 12, so that we have a high enough graph, okay? So let's graph. When x is negative 2, we're just going to count our y's by 2. This is 12. When x is negative 1, we go to 3. Well, 2, 4, so 3 would be right here in the middle. Okay? When x is 0, y is 0. And when x is 1, again, y is 3. And when x is 2, y is 12. Okay, bear with me as I draw these wonderful smooth curves. I'm not very good at the curves. So you just draw the smooth curve of the shape of the parabola. Okay. And it says to compare it now, compare the graphs of y equals x squared and y equals 3x squared. So let's do our y equals x squared. Again, if when x is 0, y was 0. I'm going to do it in a different color. Okay. But when x is 1, y would just be 1, because 1 squared is 1. Okay. When x is 2, y would be 4. Remember, I'm counting by 2s. 2, 4. Okay. When over here, when x is negative, this was negative 1, sorry, positive 1, negative 2, positive 4. Positive 1, positive 1. Okay. When x is positive 2, y is 4. And we could go ahead and extend it out to show when x is 3, y would be 9. So 2, 4, 6, 8 would be right here. And obviously, when x is negative 3, we'd be at the same place. We'd still be at positive 9. So compare these graphs just to show how it changes. Sorry, told you I'm bad at the curves. Okay, so let's look at these two graphs. The graph with the 3 in front of the x when a is 3 instead of a being 1 is more narrow. It's more narrow. It rises at a more rapid rate. Okay? We're going to use some of these things and we're going to kind of think about some things. So now let's look at this where we're going to graph ax squared where a is less than 1 and still positive but less than 1. So we're going to have a fraction. So here's my 1/4. That's my fraction. Make a table of values again. Okay? So when x is negative 2, negative 2 squared is 4. 1/4 of 4 is 1. Okay? When x is 1, or negative 1, negative 1 squared is positive 1. And so 1/4 times 1 would just be 1/4. When x is 0, the whole thing is 0. Again, when x is 1, we get 1/4. And when x is 2, 2 squared is 4. And again, 1/4 times 4 is just 1. So notice, again, our y values are identical. This time, I'm almost tempted to just count by 1/4. It doesn't say that. Let's go ahead and count by 1/4. So this would be like 1/4. This would be 1/2, 3/4, and this would be 1. Okay? So let's go ahead and do like that. So when x is negative 2, y is 1. You know what? Erase that. We're not going to do that. Just because we need to see the difference in x, y equals x squared. So let's go ahead and do it correctly. When x is negative 2, y is 1. When x is negative 1, y will be 1/4. 0, 0. Positive 1 and 1/4. And positive 2 and 1. Okay, so let's look at this graph. And what do we notice about this graph as compared to our y equals x squared? I'm doing 1, 1, 2, 4, negative 1, 1, because 1 squared, negative 1 squared is 1, negative 2 squared is 4. So notice with a fraction as my a, or as my coefficient, what happens to my parabola? Okay, the graph with the 1/4 for my a is wider. Okay, so as a increases, your parabola gets more narrow. Okay, the parabola gets more narrow. And as a decreases, as a gets smaller, it gets wider. The parabola gets wider. Okay, that's a key concept to remember. Okay, so there's our first examples. We have a positive a. Both of them are positive a's. One's a whole number. One is a fraction that's less than 1. And that kind of shows you how the parabola changes. All right, our next example is y equals a squared, where our a is going to be negative. So it's still less than 1, but now it's a negative. But a negative, not fraction, but a negative whole number. So let's go ahead and put our values in. Again, negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 1 squared is 1. 1 times negative 2 is negative 2. Again, 0 squared is 0. 0 times negative 2 is 0. 1 squared is 1. Negative 2, and then 2 squared is 4. 4 times negative 2 is negative 8. All right, so looking at this one, we can tell our parabola is going to go which direction. Let's go ahead and plot our points, all right? I'm going to count by 2's again, 2, 4, 6, 8. So I'm going to go negative 2, 4, 6, 8. Okay. Negative 1, 2, 0, 0. 1, negative 2, and 2, negative 8. Okay. All right, and then I'm going to connect my curve. Okay. All right, when we compare the graphs of y equals x squared and y equals negative 2x squared, the graph with the negative 2x squared is obviously going to be more narrow. More narrow. But most importantly, it is an upside down parabola. So when your a is negative, your parabola turns upside down. So when a is negative, then you have an upside down parabola. Okay? You have an upside down parabola. That's the difference here. Now, this is when our vertex right here, the vertex is not the lowest point, but the highest point. Okay? Hopefully that makes sense. Okay, let's go to the back page and look at a couple other examples, just a few more. Now we're actually going to go ahead and have the y equals x squared plus c. So we're going to have our a is going to go ahead and go back to being 1 for now. But we're going to have that c term. We're going to have just a constant there. C is a constant. There's no variable. There's no x. We're going to make it, this time for this example, we're going to have y equals x squared plus 5. So again, we're going to make a table of values for the equation. And this time when we do negative 2 squared, we get 4. And 4 plus 5 is 9. And then negative 1 squared is 1. 1 plus 5 is 6. The difference here is going to be this one. That's going to be the biggest difference. You're going to want to just put 0 in here. But when 0 is squared, it's 0. But 0 plus 5 is 5. And then 1 squared is 1. 1 plus 5 is 6. 2 squared is 4. 4 plus 5 is 9. I hope everybody's following along. I am just plugging in these values, each equation into the x, and solving for y. Okay, again, I'm going to count by 2's. When I'm at negative 2, I'm at 2, 4, 6, 8. I'm at positive 9. When I'm at negative 1, I'm at positive 6. But this time when I'm at 0, I'm not at 0. My vertex isn't 0, 0. My vertex has shifted. It has shifted up to 0, 5. Okay, so now my vertex is right here. Because again, I'm counting by 2's. Okay, when x is 1, y is 6 again. When x is 2, y is 9. Okay, so I have my a is still 1. So the width of my parabola has not changed. I'm not even going to graph this one on there. But my width has not changed because my a's are the same. Okay, a is the same. Okay, so it's the same width But what's happened to my vertex? My vertex is 5 higher on my axis of symmetry as compared to the y equals x squared. So can you see that A affects the width of the parabolas? A is going to affect whether it's a more narrow parabola or a wider parabola. And the C is going to affect how high up or down the axis it is. The C determines how high up or down. If we had a -5, it would shift down 5 on the y-axis. So that is how the C affects the graph. Okay? So the A affects the width, the C affects the height along the graph or along the axis. Okay? Let's look at our next one, example 5. We're going to have a little of each. We're going to have an A and we're going to have a C. So it's going to be, we're going to affect the width. Obviously my 1/2, since I'm going smaller, since my A is getting smaller, my parabola is getting wider. And I have a -4 here for my C, so my graph should shift downward along that y-axis. So let's make a table of values and see where we end up. All right, when -2 is x, -2 squared is 4, half of 4 is 2, and then 2 minus 4 is -2. Okay? When -1 is x, we square that, we get 1. Half of 1 is 1/2. 1/2 minus 4 is -3.5. Okay? When x is 0, x squared is 0. 1/2 times 0 is 0. 0 minus 4 is just -4. And when x is 1, we're back to -3.5. And when x is 2, we're back to -2. Okay? Oh, I did not put a very good graph on here. We're going to count by 2's again. So we're going to start with -2. And we're going to go down here to -2. So we're counting by 2's. Okay. All right. When x is -1, we're at -3.5. So here would be -3, so 3.5 would be in between 3 and 4. So right about here. Okay. When x is 0, y is -4, so we're right about here. Don't quite have it on there, but I'm close. And then at +1, we're at -3.5 again. And at +2, we're at -2. So even though I'm in the negative range here, notice my parabola is not opening downward. It is opening upward. Okay, my parabola opens upward. And we should know this because my A is positive. If your A is positive, it's going to open upward. If your A is negative, it's going to open downward. So when we compare these graphs, we already talked about it. The graph of 1/2 x squared minus 4 is going to be wider and shifted 4 down on axis of symmetry. Okay? So again, A affects the width. The A affects the width. And the C affects how far up or down the axis of symmetry. Okay? And that's all of our examples. Go ahead and do your daily homework quiz. I didn't even do any guided practices because I just figured we'd get you through, get you to class tomorrow, and you could do some guided practice there. So please do the daily homework quiz. It's just talking about how those graphs would be affected. I want you to look at the A, and then here you look at the C, and then here you look at the A again. Okay? So just compare those. All right, thanks. I will see you tomorrow.